So many of you are using like shelf tools, like if you want to break some things apart, you just like, I don't know, you build it up. I just make this box here on the ground, and I shatter it apart using this shatter, which is like a simple Voronoi fracturing system. And then many of you just come to this rigid body, you create RBD glued objects, which basically turns this into RBD object, and then adds gravity, and then adds glue constraint and everything that you need. So now this like kind of falls because there's no ground, so you add a ground, it falls on the ground and lands on it. You see that little movement. Then many of you might have created like another object, let's say this sphere, and say, hey sphere, you also turn into a rigid body, and then when it gets turned into rigid body, you know that it gets added on their Autodop network, which is our dynamic network. Here you see that the sphere is added, and that sphere could have velocity. So here I'm gonna shoot the sphere on this blue direction, which is z. So velocity x, y, z. So let's say 10, and then you shoot it. I'm gonna make it real time, so that's the actual time. Then you might, as you were supposed to explore, you might have come across these like nice features as well, like debris. So it's like, if I click on it, says that select the primitives from which to debris to create debris, and I select this one and press enter. Actually, what happens? A new dynamic network is created, which is again a DOP network, and you see it kind of has the same structure like rigid body simulation, which is a source and a bunch of forces and a object. But this time, these are particles. So when this hits when your sphere hits the object, you want like some tiny debris to emit as well, not just like, it's not a super clean, super cutted thing. So there are particles in it. So particles starts to emit and die. So you can use the same debris source that is created to just say that, okay, I'm gonna, because this debris source is the source of debris generation. So here you see those little white lines, they show up the moment the ball hits the box, and then they fade away. So that could be a good source for emitting dust as well. So you just select that one and say, I'm gonna, so into pyro, you can, so Houdini calls all sort of like volumetric entities, let's say, as smoke. So like, that's why I click on a smoke. So let's say blowy smoke. And then, so when you remember when I was selecting this debris source, and then I clicked on that. So now both smoke and dust gets emitted together. So, but like you see, these ones are not what I like. So like, they are very crude and very basic. So I want a proper, so let's say here, I definitely don't want that moving box. So that's why later on I realized, oh, there's another simulation network. So I have used Autotop network, and then debris simulation, and then we have pyro simulation. And here there's a resize. So when we talk about volumetric, you see that, okay, this is actually the node responsible for resizing it. So when I disconnect that node, you see that the resizing doesn't happen anymore. So that's a good time. So if I take over the area of the simulation that I want to happen, and I can see that, okay, my simulation happens within this area. So which is basically if within the camera, so if the camera is looking like that, so that's the area that you want. So, but if the camera is like larger, so you need a larger. The larger the area, the more resources will like processing or CPU, and also memory resources will be used. And then you might ask, okay, how can I add noise, more like kind of variations and diversity to this dust and stuff like that. So this is like, so we created like this simple object debris and dust simulation quickly, without like diving under the hood, with just clicking on these shelf tools. And there's a bunch of things has been created that we're going to talk about it in detail. So we're going to create all of that by ourselves. So that's, I start now going through the process, and we're going to look at some very important things, like what is this dot import? How can I cache things? How can I render things? So that's another thing, another topic to discuss. Okay, I start again. So I'm going to introduce you to a very nice website that you can use for your tests, and that's 3dscans.com. So here is like scan files of some museum objects, some very famous objects. Many of them are STL. They're a bit tricky to get them inside Houdini, but some of them are OBJ. I think this one, this reclining pan, if you just hover on this download scan, here you see that like it says it's OBJ. So let me download that one. Okay, we had a project somewhere, did we? It's actually pretty big. So I'm gonna, oh, there we are. So that's our Houdini project. So once the download is done, I'm gonna locate it into there. Actually, I just downloaded that before, but just in case to show you. Some of them are STL. I think this, what I really liked, that one, that wall. But you know, just Google how to convert STL to OBJ. Not complicated. So like you see, if I hover on top of that, it says this is an STL file. So these are like very dense meshes. So you will see like how I will manage to move this. I'm gonna move that to my project. Houdini fracture, import it, paste it here, extract it here as well. Delete the extra files. Just want this, and I'm gonna properly name it. So this is an object belonging to 1535. Oh, that's pretty old. Some of them are really authentic objects. So, and apparently the artist is Francesco da Sangallo. Anyway, I will just simply name it as swinging pan. The reason that I have chosen that, because this is like 186 megabyte object. So you see that when I import it into, so I make a geo, I call this pan, let's call it better, pan, oh, let's call it pan, anyway. You know, you add file and you import it. So I don't recall the, I don't try to remind you about the shortcuts because we've been using it quite a lot. So I press, so you know that I like to close down this part, and I like to load parameters whenever needed by pressing P on keyboard. So when I click on the job, I see that the project is not set. So first thing first is to set your project, because I already have a project created. So I don't need to create a new project. But I have like the address to the previous project that I was using. I quite go and reuse it. First thing first, save your project. So you remember that I was saving things here. So this is gonna be like another fracture. Let's call it pan fracture. Okay, so my project is saved. Just one last check before starting it. Under edit, alias and variables, you see that the job is set to where it should be. So now if I click here and I say, okay, go to the job, oh, it directs me to the same folder structure. It's very important to start working nice and neat. So I go to this imported and I bring pan back into the Houdini. But you will see that it's gonna be a very dense mesh, and I will show you how to like kind of work on this mesh and turn it into, so it, as you can predict, this is gonna be like a massive object. So I'm gonna add a transform node, make it like much tinier, like, I don't know. Yep, that's the size. It has to be rotating like 90 degree. I wanted to face to the Z direction, 90 degree here, spacebar 3 to go to the side. Let me bring it up here around. Spacebar 1. Okay, it's been lying down properly. But first thing first, you have learned that you keep observing the flow of information throughout your simulation. I middle click here, you see that I've got 4.3 million primitives. That's insane. I don't want that. So it's because like I've got such a dense mesh. Am I using all of that? I don't adapt. So that's why I save my project again and I add a poly reduce. It takes a while because it analyzes the geometry and adds the node. Okay, so the node is added, but the number of the primitives is the same because it's still keeping like 100% of that. What if I go say, okay, just keep 1%, like throw away 99% of polygons. I press 1% and wait. It reduces the polygons. You see that it calculates them. So next thing that I wanna, so once we get the geometry with proper amount of polygons, I will write it back to the disk, because Houdini likes to work with the files rather than keep processing it, and you don't want to push the network to go and recalculate again and again. So that's why I cache it back onto the disk and then reload it. So 99 bank. So that's 1%, which I think is not what we want, because it's 2 cores now. So how many faces we have? Like, we've got 43,000. Maybe I go, I don't know, 4%. Okay, so that's kind of like acceptable. If I turn off the, this is kind of like okay for me, but I've got like 174,000 polygons, which is much more manageable. Maybe I would remesh it as well. So like the good thing about remeshing is so I keep it like kind of dense, like 5%, and then I go and remesh like I'm gonna save it, because these processing that we are doing now like might end up crashing. So remesh is like oh, that was fast. So it kind of like recalculates the complexity of the scene and just does like creates the scene. So you can have like multiple iterations, but what is important is this target edge length. Or so this is a fixed length. So like, but there's a very good feature on remeshing, and that's the adaptive remeshing. It looks at your geometry, and in a very smart way, it just like looks at, okay, so this space has like a large patch, so it doesn't need a lot of faces. But here is like complicated, so it needs a lot of geometries to pull it out. So you see that like the places that are kind of large, so it has added. So that's a very good node to remesh your object, to make it like manageable. I think I can make that gradation, I don't know, 4%. Let's see. Yeah. So how many? So that's 284,000 polygons. Maybe I add another iteration. So I'm saying that go back, rethink the whole algorithm, and create a new result. So it adds another level of calculation. Oh, it's still. So I might go like density. I lower down the density to like half. Okay. So that's 100,000, and half is like, I think, too much. I lost the face. So 65. Sorry. Okay. So still manageable, 187,000 primitives, and you see like how nice and neat, like it adds polygons where it needed and takes away where it doesn't. So I think that's what I want. So you can write it down, so you can add another file node and say that I'm gonna write it down here, reclaiming pan. It's gonna be low res. Actually, right way of naming is using kind of these underscores, because spacebar is, programming languages doesn't like spacebar. So I'm gonna go and say write it down. So the moment I have chosen write, you see that it gets written here. And just compare these two files. This is 190 megabytes and this is 7 megabytes. So this is much more manageable. So even if I disconnect it here, so I go back and say that, okay, you have written that on hard disk, now read it. So if I disconnect this here, you see that, like, oh, that's the file that is loaded from hard drive. And now this one just occupies about 10 megabytes of the memory compared to this one, which occupies like 234 megabytes of the memory. So we didn't lose like too much of details. So it's still a very manageable object. So I export that out as, okay, you know that what's going to happen in between. So there will be a lot of I'm going to call this reload in low res. So that's very if at some point in the production you decide that, okay, I really want to load the very high res and process that one, your processing happens as simple as like reconnecting this back to the network and just skipping all of that optimization process. So here in between, you know that the fracturing should gonna happen. So I'm gonna call this out pan geo. So it means that this is what's gonna export the, and you know my way of coloring things. I like that to be round and gray as a portal. Let's fracture it. So what's gonna happen? I don't know. Maybe we load another object. There's one animating object as a test object within Houdini that we can use to smash this. So you use like like there's a crag or test. It's a test geometry, and it's an animate. So it's kind of like what you do from my. So it's just an animated object that it's an object that has some animations. It's actually a Alembic cache, so it's a bit long. So maybe you need like longer animation. So I click on this little icon over there, global animation options. I might say that go for 400, and then I see, okay, so that's the moment, but I wanted to hit on that pan, so it doesn't like pan. So I just might add a transform node on here, and rotate it so like 180 degree, move it back. Yeah, it's gonna punches, hammers, pans, bolts. It's angry. Okay, so this gonna fracture that. So we have the object, we have two objects, and okay. So let's pre-fracture pan. So you remember that. So I'm gonna use like saving it, because A simple algorithm to fracture your object is Voronoi fracture, but a more complicated, more pleasing one is arbitrary fracture. So I'm gonna use RBD fracture here. So I'm gonna use RBD or rigid body dynamic material fracture, and I bring it into the network. So it takes a while for the first iteration. So a very good habit to analyze your fracturing is to add an exploded view somewhere in this, like exploded view, and connect that. So you look through that exploded view. So this pan has been is gonna fracture like this, and the material that I'm gonna, so it's not the shader when I say material, it's the substance that this statue is made of. So you know that you have 3 pre-processed substances, or like kind of materials, concrete, glass, and wood, and you got those like glossaries or documents about the way each one of them behave. This is going to be a kind of a marble statue or a stone, so the way it behaves, it looks like concrete, so that's why I choose concrete. But that's definitely not the way I'm going to fracture it. So because like at this time, this is the area that gets like the most amount of fracturing. I'm gonna guide it. So first of all, let me tell you what this concrete does. So it has, so you can have multiple levels of fracturing. So let me go to the second and I delete that. So you see that it fractures first, and then the second level, so like each one of these big pieces fracture again. Think, you see, and then the more, so like the more in a hierarchical way, the more layers you add. So it's basically like grabs the ones that has been fractured and fracture them again into like little pieces. Okay, so 2 level is fine for me. I want some chipping, so these edges would like kind of chip, so I enable that. You see, like some edges like have this kind of chipping effect, but I want to direct that, so I'm gonna say that fracture more on this area and less on the rest. So what I do, I add a paint node and I connect it to my object. So this is the area that's gonna get the most amount of fracturing. Let's make it black. Go back to the white. If you don't see these icons, you might be like on this. So like press enter and you will see it. So I make the area that I want to get the most amount of fracturing to white. Yeah, that's the area. And you just select smooth and a couple of times apply to all and smooth it out. So the area gets smoothed out. So that's what you feed into scatter. And you will see that in the scatter, some of them are black, some of them are white, but I want only white points to remain. You can say you want a direct density of the particles. So here you can say that I'm gonna use color. You know that color in Houdini, we have used it like multiple times. It's simply called CD or color data with capital C. So like 1,000 points on the white area is, but like maybe 100. So that's a good amount of points to direct RBD fracture. I plug it in back to RBD fracture, but nothing happens because I have to say that go and use those points. Let the RBD fracture think on its own. I go here and I say that, okay, so that's layer 1, use input points. I can go to layer 2 after like it calculated that. I should have saved it. Yeah, the chipping is the one that takes some time. So I could have added that later on. So that's the amount of passes that is happening. I think it's done now. So I'm gonna do that. So like if I explode the view, use the exploded view, you see that like the area that has we painted gets more details and the rest gets less detail. I'm gonna use the same points to drive the second layer as well. Some of the objects that you can use for your projects, these like kind of generic wall. Oh, wow, that's a cool one. Is it OBJ? No, it's still, it's a bit cumbersome to convert, but so you can. So you have seen that many artists use this or that double dog statue made by George Lucien on 1911. So like you see that a lot of artists have used them for generating like CG elements. Okay. And there are heaps. High resolution scans. Okay, so now you see like we have a very nice fracturing happening, but I don't like this flat kind of very computerized, sharp Voronoi-like edges and interior. That's why you got this detail, and you can say that you can add edge details. So yeah, and then interior details. For interior details, it's good to like make the voxel size larger, so I can show you what I mean. The mesh is dense, that's why it takes time. Okay. So you see that like all these details on the edges has been added, which make it much nicer. Like kind of it's jagged now. Anyway, Now we've got our prefracture ready. So this exploded view helps us like understand the way it's like look inside, analyze it, and understand. Then you can delete. Now you know that we have to assemble them or turn them into packed geometry. The reason is that these are like 240,000 primitives. So we turn them into packed geometry by adding an assemble node and then create packed geometry, and then it becomes 453 primitives, which is much more manageable for the memory. So this one occupies about 50 megabytes of the memory, and this one occupies just less than a megabyte. So like about like 100 times more efficient. So if this statue fractures, let me just like do a simple fracturing simulation now, and you see that it needs a glue constraint. Okay, I go up. So you remember that last week we created the network, dynamic network inside here. Doesn't matter. I like to create it outside for today. So I create a dot network and I call this pan fracture simulation. So here you see that everything is just like grayed out, so it means that there's nothing in it. And if you just say that, just show what is loaded in, you can kind of say that hide other objects. So then it's a good way of understanding what is getting loaded. I go back to frame 1. When it comes to simulation, it's good to have to go back to frame 1 or to the beginning of the simulation. This is also a very important thing. So the first smashing moment is at frame 243 or 4. So like I can say that start the simulation as at frame 240. So you can select the top node, not inside. It's not inside. It's on top node, and you can say that start frame is 240. So this brain doesn't work up to there. For this simulation, this brain does nothing, and then suddenly starts here to think and calculate. Well, although there's no solver inside, but so when I get inside, I can say the first thing is RBD object. So RBD packed object. So you load. You go say that this is going to be RBD pan. Or we're gonna go and say that, okay, go and find pan geo and load it in. Why it doesn't load? The reason might be because here when I added, oh, it's been packed. It's been packed, and the eye should be on this. Yeah, so that was the issue. So I was looking. So even though, so the top node here, the highest level node, just always looks at the latest visible or latest node with the eye turned on. So I was on this one, which I should have been on this. So the assemble or pack node was just kind of ignored. So here I get inside and I say that go and still I don't get it. Why? Oh, okay, that's the issue. Okay, actually, the reason is that I show you this how to get this retime fixed. So because we said that there will be no simulation before this time. So it was saying, what's the point of loading it? So then it loads it after 240. Okay, that's the first one. Then we need a rigid body solver, which is the brain that calculates the simulation. I save it. Then you remember that we were adding like gravity, or then a ground plane, and that ground plane is supposed to merge with the rest of the simulation, or mutual. And when we play, so nothing happens. So I'm going to start actually, I'm going to set the timeline here to start from 240 from now on. So now it just falls and shatters apart. So what we're gonna do, we're gonna glue it together and then define some areas. Okay, so first thing first, what is glue object? Glue object is basically a bunch of lines that connects the pieces together, a bunch of adjacent connected lines. And the node is literally, so you can have two outputs out of one. So this next output uses a connect adjacent pieces. So you can click and look at what does it, what it does. So it basically just creates a bunch of lines between those pieces. But I want to create like not one, but just like maybe 2 or 3 lines. And these lines, I'm gonna just like increase it like, so I'm gonna like, you see that like it just scrolls through. So that's a nice network that glues things together. But these are just like a bunch of lines as nothing more. You can call it glue if you turn them into a constraint name. So that's why we create a new attribute, because we want to, so if we look through the flow of attributes all the time. So here if I middle click, you see that this one has a name on it and point attribute. The previous one is just like name, point, and path. So here I say that, okay, go and turn these into constraint name. Constraint name is an actual attribute later that is existent somewhere in network later on. So here when I add inside my network, when I add a constraint network, here this constraint network has a constraint name that is, I'm just saying that created that constraint name using these lines. So it's gonna be primitives because these are lines, not points. These are primitives, faces or point or lines, and they should have a name, and that name could be like, I don't know, pan glue, and that's another output. And this one's gonna be pan glue, and I like the shape to be like a glue stick and gray again. So I go back the visibility to here to the statue. So now I need to load it into my network. So I need to add a constant network which is looking at my pan glue output, but still needs something. So if I middle click, you say that no, not enough resource specified, and that red one is what it needs. It says constraint to create. So we actually have to go and create a glue constraint that is connected to there, but I don't see it loaded. If I press W, because the data name, if you remember, I named it pan glue, and suddenly you see that, oh, they are loaded now. So if would be pan, if the data name would be wrong, they get, so you see that they are missing. So the glue is not loaded. It could, so then the strength is here. It could be very strong. So when I'm going to save it again. When I simulate, you see it just falls on the floor and doesn't do anything because it's glued together. But if it would be like kind of 0, actually, I don't know what's happening, but it should. Let me see if it is from the constraints by turning that, by bypassing them and playing it again. Yeah, so kind of constraint is holding them tight together. Very tight. But when it comes to 0, it should not function. Okay, I think it's because, anyway, so I think if I add the activation to the line, things should work as expected. So next round, before I pass the class to Caroline, we continue this process, adding like all the particles and smoke and dust and everything on evening section, if Mari has no plan to go over color grading. But let me just wrap it up by I gonna say that in this like so you remember that I'm gonna make this deactivated, and I'm gonna select some areas that they remain. So when it gets smashed, I just want some pieces to stay there. So use these 3. You remember that we added a attribute create here. So this attribute create says that, okay, so it's gonna be active. This active is what is an actual attribute name later on in your network. Here you see that your object is active. So here, within here, you say that, okay, all objects, all points, because there's a point within each one of them. All objects, what is that? That is something I don't like to see.
That be because of the revision?
Maybe. No, but that's been reloaded, so that's the object. Hi, Caroline. Assembled. Hide other objects. I think that's the glue. No? But I'll find it out. So it's these issues will rise when we start the simulation at another point, because a time shift should be added. I will add it. Oh, it's gone. I will add it within once we get there. So I just wrap this up. So this attribute is gonna activate everything. So it's gonna be like a integer or float or whatever you like. So the default is 1, and this is gonna be 1 as well. You can like hold Alt and duplicate that one, and hold Y disconnected and connect it back and deactivate it. So it's basically the same. Deactivate. So this one activates everything, this one deactivates everything. But in the middle, I create a group, and that group is kind of like the activation area, and that group uses a box. I click on here. You see that if I move around, this box selects some pieces that wants to be. I just want that lower part to stay there and doesn't get smashed. So some pieces I want them to stay. Like that. Okay, so just imagine that when it gets smashed, so these pieces remain. So that's group 1. So in the deactivation, I say that go and grab group 1. So that the activation is also ready. So this is where we left off. We had the pan pre-fracture, and we had a kind of like using these 3 activate and deactivating. So actually I just added like the attribute activate. So this attribute is there somewhere later in the in the simulation. I just told that, okay, take it all 1 except these ones, make them 0, and that's it. So now I'm gonna use it. So this is your first this is our first simulation. So if you see like a cut like that here, it's because of pre-fracturing. So if I make sure that the detail is at the edge detail, I think that's the edge detail. So if you see such a thing, you make the detail size larger or smaller. Let's see. One of the reasons you might like, you might prefer to use Voronoi fracture is like, especially when you do like quick. Actually, we could do that. So what I do, I use a simple Voronoi fracture here, and then I add. So I kind of direct my Voronoi fracture. So I kind of go to the beginning, and this is my Voronoi fracture, and so you need you know that a Voronoi fracture needs some points. Actually, I use the same points. So this one is kind of faster than RBD material fracture, because inside RBD material fracture, heaps of things happening. So, well, but once you have enough time to wait, so I'm gonna just go over and keep teaching. So that's why I use a more faster kind of algorithm. But once you're on your own and you wanna create stuff, it's good to use RBD material. It's a very nice and neat one. So let's have a look at exploded view. Okay, So it's kind of similar to what we had, except that I don't have that little nice inside fracturing, which I can achieve by RBD details, interior details. I can add it here. So let's see. Okay, so if I attach the exploded view to this one, so you see that some details are added here. So if I bypass it, you see no details, with details. So detail size, it could be like small, and some adjustments, some noise, and like very low frequency. I like very low frequency details, or like high frequency, depending on what you want. It's good to have some fractals on it. Detail size, good, make it tiny, tiny, tiny. Yeah, to add more details inside. So if I put it back, what would happen? Nice and neat. Okay, so I've got some interior details as well, which is nice. So this Voronoi would work faster for me. So feel free to use this or the RBD material fracturing, which is a more advanced version of fracturing. So I go back to what I had. So now in the fracturing, so we have the, so if I turn off the glue, I just want to make sure that it breaks apart. Okay. All good. I stop it. Okay. One very important thing, go to Edit, Preferences, and Save and Load options. Here, make sure that automatic scene save is on. So every 1 minute or every 2 minutes, it gets saved. So I save on the same file, but if you want incremental file names, so like when it is, let's say this is pan fractured, then it version 1, then it keeps creating version 2, 3, 4, 5. I don't want to like populate my hard drive, but if your scene is too complicated, and like if you are afraid of like losing some data, that's incremental saving is a very good solution. Okay, so let's glue it back together so it doesn't break apart now. It just falls, you see? Bang. And like it's kind of glued, and when I, okay. Now it's time to, actually I just have had it done. The glue is over there. So, and the strength is good. Okay, now we're gonna load this one at frame 2 something to smash this apart. But let me show you different form of creating interaction. So let's say we have I don't know, a sphere here, sphere which is polygon mesh, and it is smaller. I'm gonna see the other ones in a ghost way. Move it up. Okay. So sometimes you have animated that one. You might have, say, if this would be just an object here on top. So let me just like let's analyze like a couple of scenarios. If this is a dynamic object that is falling or just getting shot from here, so I'm gonna shoot it as a dynamic object. So here in your simulation, you just load it as another RBD object. RBD packed object. It says RBD packed object, so it means that it won't read that sphere because this has not been packed. So I go and pack it. So that's what gets loaded here, and I merge it with that one. I'm gonna hide Craig for now because okay. So this is when the moment that it gets merged into rigid body solver, it means it turned into rigid body dynamic object. Okay. So and when you go to the attributes, it has a velocity. So it has an initial velocity. I'm gonna shoot it on -z direction. So x, y, z -10. So actually I'm pushing a initial velocity into it. It gets shooted. Oh, why it doesn't get loaded? Because I have not mentioned that. Let me go to the hide other objects. I've been fooled by the ghost of the object. So I gotta go and select it and bring it in. So because the RBD node was added but not pointing at any specific object. Okay, so now this object should go and hit the sculpture. How the sculpture should hold the impact, it really depends on this glue that we made. Like you can make it loose, so it just kind of makes it smashes apart. But what if this object, I'm gonna delete that one, keep that merged for now. What if this object, this sphere, would be animated? So let's say this sphere is, I pressed F, is moving from, I'm gonna see other objects, so I would be able to animate it. It's moving from, so I hold Alt and click on all of the translation. It's moving from here to here, like quick and fast. So you see the animation? Okay, so if I go, this is not a dynamic object anymore. It's a static object that we want it to be solid. We want it to be rigid. So you load it differently this time. You load it as a static object and point to it. It's OP and that's sphere. So that's static object loaded. But how I kind of merge it to the rest? I'm gonna hide. So there's another static object here, and that's the ground. That's that infinite ground. So if I merge it to that ground, that should solve my problem. So I'm gonna go and merge it with the ground. And it could be a mutual relationship between them, or like what I usually do, just create a nice. Okay, so then this static object, you can say that it's a, I don't know, if it would be an animating object, you can say that it's a deforming geometry. And you can say to re-evaluate your geometry every frame. So it means that every frame go and load it again and again and again. So don't load it once. So that's good for like moving and deforming characters and stuff like that. But let's see if it does the job without them. So it starts getting animated, but I don't see the animation. So that's why I have to re-evaluate it constantly. So it's a animating object. So that's for loading an animating object. So what about our Craig? So the character that we have over there, let's load it with different. So is there any art? Yeah, there's no art here. I'm gonna add a null object as I do always, because we probably at some point come and do stuff here before the output node. So I do turn it into, okay, and I call it out Craig Geo, and I use it. So you can use it as a static object here. Oh, actually, I just want to delete that sphere. Keep everything clean. Here, I load it as a static object. Let's see if it would be a deforming static object, what will happen. Sometimes, oh, I realized I deleted the ground. That's okay, ground plane, come again, getting added. Okay, so I load it and I merge it with the with my ground plane, as I did. Oops. A mutual relationship, and I go and say that this is gonna be Craig. I like to make that uppercase as well, just to keep things neat. Okay, so it's loaded, but let's see. It doesn't do anything because it doesn't say, but actually it's a static object, isn't it? So when I say use deforming geometry and reevaluate, what would happen? So it goes and bang, it smashes things apart. But for some reason so that's one way of doing it. There's another method if that doesn't work, because for me that didn't work another time. So sometimes if that you see that, oh, you added it doesn't work, you can load it as an RBD object as well. So I'm gonna disconnect this for now. I'm gonna show you that you can load it as a RBD object. Go and find Craig, but this time say that this is gonna be an deforming static object. It means that, again, pretty much the same thing, and then merge it with the rest of your simulation, so you get the same effect here again. So one thing I'm gonna fix: this pan should not be able to move. So it's been assembled here, yes. It's been deactivated. I'm gonna turn this off to see if it gets okay, I think we have cached it sometime, did we, or we didn't? It keeps loading the same thing, which I don't like. Okay, so I'm gonna disconnect this for now. This is supposed to do nothing by default. Okay, I'm gonna find the I'm gonna recreate all of this. So attributes create again. Okay, active, and the active gonna be points or primitives. That might be the thing. I'll find it. Integer by default is 1, but now it's 0. Okay, so it should get deactivated in the simulation. Yeah, it got deactivated. Okay, that's what I want. I want it to do nothing. And then I go there and say, okay, it's deactivated, and I hold Alt and duplicate that one, hold Y and disconnect, add it here, and say, okay, I'm gonna reactivate it again. So if I go back to simulation, this should be activated again. So, okay, things are working so far. And in the middle, I'm gonna say that group bunch of them. So temporarily I move visibility on the group. I'm gonna say select the bounding box that groups a couple of these points. Kind of yeah. Oh, that's too much. What about if it would be primitives? Here, actually, I can say points. Oh, yeah, my bad. I think that's the issue. So it's points here. It should be points there as well. I think that was the issue from last time. So why this attribute should function on points? Because actually when they get packed, we see something terrible here. I know. I create another assembly node and make them packed. So, and it's gonna come from here. Okay, you're nice and neat, but I don't know about you. Okay, I delete that. And that's gonna be, okay. So, when we pack them, so these are like loads of geometries, isn't it? These ones. So when I pack them, actually, I should not get it from exploded view, but for the sake of explanation, I do that. It just adds one single point in the middle of each one of them. Actually, when you come to point, oh no, not this one, but so like a single point right in the middle will be the representative of each piece. So that's why here should function on points, and this group should function on points. So this group is supposed to work on, I'm gonna add it again. What was that? Let's add. Ah, there you are. Okay, so it should function. So when it moves up, it actually grabs the piece that the point intersects with the box. Gets deactivated. Go back here. This should stick pretty well without falling. Oh god. There could be a trick to fix it, which I hesitate, and that's moving the translate. I just do this for now. Don't die, please. So there's a chance that when we remeshed it, it has been. I'm gonna turn this automatic update on manual, so every time I click this, it just gets updated, so it doesn't. So probably this mesh has some issue that might cause that thing. So what I can do is I might reduce the mesh one more time. Let's do that. So we get a cleaner mesh anyway, but we lose the details. Anyway, I just keep that for now. Just move it like right. Okay, I think I got the issue. That might not have been converted to polygons, so I add a simple convert here in the middle. It says converted to polygons, just in case. Nobody knows, but why it doesn't move? The reason is the update is off. Okay, so even if it falls, so one really important thing is you don't want penetration with the plane. Otherwise, it just goes crazy and it gets stuck into the ground plane. So the moment I click here, it just recalculates everything. I just save it. So it goes through the process of fracturing it. And then adding some details. I might skip this idea. Well, that detail was just got added quick fast. Assemble it. That one is working fine as well. What I do, again, I recommend that you use RBD material fracture that creates more complicated objects. What I do here, I delete this detailed, just in case to speed up the process. So I delete that one for now. So this interior side will look more simple. But that doesn't mean that you have to do that. You can clearly create more complicated pre-fracturing. But for now, just for now, let's see where we are. So that one is selected. Okay, that one is supposed to be 0. Okay, I think I found my problem as well. So I added some attributes here. I set them, you have to be 1. Everything should be active. So the first one, the first active activates everything. Activate. So the first attribute create, which is activate integer, is gonna be 1. The second one is gonna be 0, so I was using it the other way around. So that might be the issue. So I should not see this falling in the simulation now. Yay. Okay, cool. I can't stop myself adding details here. Sorry, I'm gonna add it. RBD details, interior details. It makes it nicer. Yeah, just a bit of detail doesn't hurt. See, maybe with a very little, yeah, even more, and a very low frequency noise, like half, or high frequency noise. Sorry. 8. Ah, that's nice. Okay, I got it. Oh, that's too much now. That's because of this 88. Okay, that's nice now. See? That's why you should not. Maybe 555. Okay, this is definitely much better than a simple and the noise amplitude could be just a little, not too much. Okay, okay, I'm happy now. Go back to there, make sure that it doesn't fall here. It stays there, great. Bring back our static creature, which is that. Okay, so this should hit, and the lower part, okay, why it doesn't do anything? So probably that's where, instead of this method, that one would help. So I imported the smasher as RBD packed object again. I call it RBD Craig, and this one is deforming static object. So let's have a look at what it does. You have to smash it. Okay, so what's wrong with it? Let's review what's wrong with it. So we have activate, so that one's gonna be activate. That one is the group. Okay, so this is the issue. My bad, sorry. So the first group activates everything, isn't it? The first attribute create. The second one deactivates everything except the group. But here I didn't say that go and grab that group. I selected that group now. I say that here the second one says that deactivate everything. So that's why you saw that everything was deactivated. But here you say that deactivate just the group, and the group is what you see here. Oh, no, here. Come on. It's because, yeah. So that should smash it. It does. But there was a bit of like so you saw that the parts that we grouped to not smash, you saw that it started to move at the beginning. You see that one? That's what I don't want. So maybe I make the glue stronger. Maybe it's because of that. Yes. But that's too strong now. Let's make it like 3000. Okay. There's still one thing here that I don't like, and that's like kind of things start to fall apart sooner, which I don't like. Maybe I move the group that group just like is too big. Just some of them. Maybe I cover just some of them. Let's see. What if I return it back? Okay, it doesn't matter actually. Okay. So there's one way of solving that issue. Okay. Is one thing that I have pointed, the simulation starts at 240, isn't it? So just the simulation starts now. But what I can say that don't start the simulation until 244 actually, or 3. 243. Okay, you see that everything goes away. And there's one way of solving this, and that's a time shift. A time shift. Oh, you don't have time shift here, but that's okay. I can show you when we bring back the out of simulation. We add a time shift, and to be able to see it before the simulation begins. So like, oh, that's too late. So maybe 242. Go back. Okay. For some reason, I think 240 was working better. Okay. I think if we add some particles and stuff, that issue will be hidden. Anyway. Okay. So next step is to add I'm gonna add a lot of like debris. So what I do, so you see that like this. So first of all, if I'm gonna carry on. So first of all, if this is the simulation that you like, let's say you're gonna simulate up to frame. Let's say up to frame 270 or 280. Okay, that's the whole area that we're gonna simulate. That's our shot. So what I do, you know that this project is set to here. So so if I go to the edit and jobs, so it's playing. So so it does some. So when I change the project folder, it has to recache. That's why it just was recaching. So if I go to the alias and variables, on variables, but the project is set to that folder. So that job, isn't it? So at the end of each DOP network, dynamic operation network, you see this output. And that one is what we cache the simulation, this .sim. So it's kind of that this turns your constant calculation to some data on hard drive. So instead of .heap, I say $heap, I say $job. What does it mean? So I'm gonna say that, so here I'm saying that, where was the job? It was here, where I set the project. And inside that, which is here, so you see that sim folder, which is simulations basically, isn't it? So you see that simulation folders. So you can cache your simulations over there. So when I say that save to disk, what would happen is basically does this. It just goes throughout your simulation, but I'm going to interrupt it now because you will see that the start and the end is 1 to 400, which we don't want. So we just want it from 240 to 280. So you can click, hold Control and Shift and click on that and type 240 to 280. So just that area we wanted to cache. So that's why the caching just happens much quicker. So what it does, it basically goes through this timeline and just plays it once and writes it on the disk. So from now on, I can like scrub through the simulation and see the result much easier. So you see, it just like I can click wherever. So there's no simulation happening anymore. It's just like loading it from the cache. So, but this, you have to keep in mind that this it still lives within this dynamic world. I have to take it out of dynamic context. Let me show you in Photoshop. You remember that I explained that Houdini uses like kind of these different contexts. What? So let's say you are in SOP now, which is surface operators level, or operators or surface nodes, whatever is related to rendering the surface or showing this surface of the. So you create geos and like volumes and stuff like that. But sometimes you send your stuff. How can I change colors right away? What is the shortcut for that? Anyone knows? Without. Okay, I'm gonna make that one purple. Nice. Okay, and I'm gonna use X. Oh. Okay, cool. So you want to travel from your SOP level to other environments. What is DOP is a dynamic operators word. It's a new word. You see them next to each other. They live alongside each other, but they're actually like, so when we are in obj, which means that we are in a like sublevel. But from sublevel, the moment I add dot network, I'm traveling into a new world. So once the dynamic is done, you have to go back here to be able to render it. For rendering it, you use a new word, ROP, or rendering operation word. So in dynamic, you create pyro, like fire and smoke and stuff. You create rigid bodies. You create particles. Here you render. So sometimes you see like shops or material. So you see that like you travel from surface level to shops or shader operators. Shader operators. So you create materials here. Sometimes you do like motion graphics or animate your object, and they use these channel chops or channel operators. Weird naming, but that's what it is. That's how Houdini functions. So the reason that I have to bring these elements out is because I'm going to render them. So if I turn off the dynamic, this is not what's going to get rendered. Dynamic is not a nice environment. It's doesn't get rendered actually, a dot network. You have to load them out. So what is used for rendering them, or you can create a new geometry. So here I'm gonna say pan to sub. I'm gonna load pan, the breaking one, this one, back into sub level. That's what I do. I go there and I use a dot import. It means that go to the dot network, find, so which dot network? We use pan fracture simulation. And now it loads everything. Star means everything. When I say fetch geometry from dot network, it loads everything. But I might say that tilde key, dot object created by, go and just grab from all of this, just grab pan, which is parentheses quote under object slash inside fracture. Inside fracture we had that RBD pan, if you remember. It was like the creature. I close the quote parentheses, I close parentheses and tilde key. So just, you see that just pan is loaded. So this is loaded and it's already, the simulation is cached, not the object. It's good to turn the object into a cache using file cache. So here it just gets like, this is the cache that you can exchange between applications as well, like send it to Maya. If you remember, we used 240 to 280, and yeah, that's, and also, so I'm gonna make a folder called cache. You see that simulation that just has been cached? I'm gonna make a folder called cache, and inside that I go and select that folder inside jobs, cache. This is pan fracture cache. Copy that. And $F. It means like 00. You know, it means frame. Sorry, it means like dot frame 1, dot frame 2, 4, 3. $. So this is like a Houdini preferred cache extension, BGO, and SC means scene. So you create that, you write it on disk. Again, it does the caching quite fast. It's done. From now on, it's just a rock solid data on hard drive. So it speeds up your simulation a lot more. So I'm gonna add as you know, just for the house cleaning, I just add so for the cache I use this cloud icon. I like it with blue. It means like, okay, we're safe, caching is done. So this is cache pan fracture. So pan is out now. Craig should be used as it is because I think there's no dynamic on it actually. I just load it as it is, isn't it? Okay. Now I want to create some particles. So one very important thing, if my project starts earlier, let's say 200. If I go back, you see that, oh, just pan disappeared. The reason is here, that's what I said. You need to use time shift. Time shift says that, okay, so if I go to attributes, I can say clamp. Clamp means like make it as it was. So I can make clamp both sides. So before 240, pan is loaded as unanimated, as like. So I'm gonna go beyond 300 as well. And after 280, sorry, 280. So here it just like kind of switches to like the breaking pan, and that's, you see these like moving pieces. At 280, they get frozen forever. Well, actually, there's some simulation running here still, because it loads back the simulation because it's connected to dot network. If I disconnect that, it just, you know, you see it gets error. But oh, let me just move. Okay, so that's the right way. The reason that the simulation was still running because I was on the file cache. But now you see that after 280, so they move. After 280, they freeze. They use like, so I say that after 280, stay where you are. I'm happy as it is. So that's the time shift, which is very important in your simulations. I'm gonna source particles. I'm gonna start and say that, okay, so that's gonna be, so let's categorize things. So this is pan. This is pan. So these are our geometries, and this is like the fracture. I'm gonna source particles. Make a new geo. What does it mean sourcing particles? So sourcing in Houdini means like emitting, or just like finding an object that functions as emitter. So here I'm gonna do that. So I'm gonna like say that the moment that this hits the sculpture, the statue, that moment start to emit. So that's why I'll call it pan sourcing particle, or just sourcing particles. There's nothing inside. So what I do, I go and merge that object back to so I'm gonna go and grab this object. So you see that it has traveled back to the sub level. I'm gonna use that one. So I go and grab it. I go say find the pan that has traveled back to the sub level and has been cached. So it's loaded now. But this is a packed geometry. So if I click on it, you see that like primitives. So definitely this is not 100 pieces, 100 polygons. Because I want to emit particles, particles are emitted from each individual points. But like, so that's why I unpack it. So you remember here that we packed it with this assemble node. Here we unpack it. Okay, it's unpacked now. So now I'm ready to use this debris source, which is basic. It's a very smart. I'm gonna stop, press escape, and go to, so set this back to 240 to 280, our timeline. Go to 240. Press escape again because I'm just gonna turn off this, make it manual. Here, this node is very smart actually. It just looks at every point in your object. Okay? As long as they are in the same distance, it doesn't emit any particle. The moment they start to go far from each other, it realizes, okay, so this is where fracturing is happening. So I'm gonna emit particles from the same moment that it cracks and it shatters, from the same place that it shatters. So it has a rest time, which is frame 1. It looks at start time. So I again hold Control and Shift and click on that and say 240. So start at 240. Okay. And I click on that. So from 240, it looks at. Just go back to the beginning. Okay, the reason that it doesn't do anything because I said that do not update. I'm gonna do that manually. So I go and say auto update again. What's wrong with you? Okay, back. So what I do, I turn off the brain this time. Debris source and make it 240. Oh no, 240, and then turn on the brain and then click on it. Okay, so now when I play, so you see that the particles start to emit. Where? So if I template the previous node into the next node, templating that purple one is like go show that node when I'm working on this node. So I'm templating that one in here. You can see that, okay, no particle is emitted. Just when they start to fall apart, new particles gets emitted. How long? For 1 second. And after a second, they die. So these particles are a good source of emission. So I might make them die like faster, like after less than a second. Because I want the particles to emit and die quickly, maybe faster even. 4. Okay. So the output of sourcing particle is basically just, if I turn this off, is basically just a bunch of particles. That these particles emit other particles. Do you get what I mean? So here I can say, okay, I'm good with this one. Let's add a caching here as well. File cache. You see that I keep caching things because I want, if you're happy with an attribute, then, because if you go and use it in your network without caching, it goes and recalculates all of this. But if I say that, okay, so this is gonna be job cache, source particle or source debris cache, and username naming as before, $f.vgo.c, and I think we're ready to cache it. Oh no, we're not. Don't want to cache that many, so we just cache 240 to 280 and we cache it. So, and it happens very quickly. Okay, done. So it's been cached. I think it's good to output it. As you remember, I like to use kind of like a cloud. It seems that it comes from like a cloud or just outside of the program instead of like that circle that I use. These are just like, I don't know, stupid things. Cache source particle. It shows particles, but I call it debris anyway. Debris. Let's call it sourcing debris. So now I use these debris to emit particles. So particles are dynamic objects. So here you create a new dot network. Interesting. So here that dot network is pan debris. So when I get in, there's nothing. I'm gonna go. So pretty much like what you did for. I go back to frame 240. This is a simulation, so it's gonna start from 240. And you remember inside this simulation. So if you look at from like high up, you got like a brain, an object that gets in, some constraints, and that's it. This is the beauty of Houdini. Everything is unified. You don't need to learn heaps of things. You just keep repeating the same logic. So here you need object. So, but for particles, they called POP or particle operator objects. Particle object, POP object. So this is like the object that we want. But this object, particle object, there's no particle here because how it is supposed to know where to source it, where to find it? Well, happily, we created the source. So we can say that source volume or pop source, particle sourcing, and where, so you're gonna say go and look at the sourcing that I created, and it's cached, so you're happy. And so it says scatter onto the surface, but there were no surface, it was just particles. Go and use all the points. Okay. And we need a brain solver or pop solver, which is a particle brain. And I think we should be good. Is there any particle emitting now? Yes, but like heaps of particle is getting emitted without like a very good behavior. So the reason is that, okay, so these particles, if you click on this, they don't have a good velocity. Actually, they don't have any velocity, because if I click on here, they don't, but they actually have the v, which is the velocity, but the velocity is not functioning here very well. What you can do is when you source it out, so when the particles are sourcing, one way is, okay, so I'm gonna go and start playing around here to create some velocity. They are loading from cache, yes. Are they reading from cache? Yes, yeah. Actually, I can leave it as automatic, so the moment that we write it, it writes. The moment we read it, it reads. Okay, so here you can say that first of all, a time shift. So the reason that it's just like it's a good habit to say that, okay, what's going to happen before and after that, because this simulation is it's not starting from time 0. It starts from like later on. So that's one thing. Here is the thing. Here's the important point, that you kind of know how to create like kind of attributes. You can say that add an attribute wrangle. So what is that? It's just a programming environment. We're not going to create complex programming. It's Vex programming, which is like the programming language in Houdini, and it's a very simple C-based programming that uses the same thing that you keep hearing again and again and again. So let's say these particles have a life, isn't it? So we're gonna emit some particles out of them, but what density? You might say, okay, look at their life, and I'm gonna emit with the same density. So when they are too much, when they are alive a lot, when they are at the beginning of their life, emit a lot of particle with high density. When they are dying, emit nothing. So you can say that if the at sign, let's say density, so it means that, so this particle has a density, but I'm gonna redefine it. By f I means float. It means it's a new kind of variable. So it's gonna be $age, and you have to use this like ending to be able to end it. So this particle here, if you go to so this is your friend. Don't be scared of by looking at it. It just gives you some numbers. But this will be your friend when you go and analyze what's happening in your scene and understanding it and analyzing it and finding your simulations. So in this geometry spreadsheet, so you see that the age of the particle now is equal to density of the particle. But I kind of want it to be the other way around. I want, so like if the particle is like 0, the age is 0, is dying, I want the density to be like more. So like kind of the opposite of it. So, and it's simple. You can like add 1 minus h. So that's a defining density. But these particles later on are supposed to emit some other stuff that they need some scaling, sizing. You can create that like those other attributes here as well, like p scale. Particle p scale is equal to density. We already have created density. So these attributes can be used in your network. So if or not, so it depends. So you can create attributes like this, or you can use like, so basically the attribute create attribute is pretty much similar to this attribute wrangle. You see here you have float and integer, and so that f here means float here. And then you've got default and value and like kind of naming and stuff like that. So it's a visual way of this code. Okay, if I go back to my debris, here you see that particles are emitted. So let's analyze it. Okay, so some particles are emitted, but like they don't move around, or they don't die. It's so what we want to do, we start to add things. So first of all, it's gonna use all points. And one really good thing is that I'm gonna say go and inherit velocity. So it says that use velocity of the thing. So those points, they have a velocity on them. So I can show you sourcing here. If you turn this on, they don't actually have velocity. So we can create some velocity here. So it says that they have velocity. Well, actually, no. Okay. Here, what about here? No. What about here? No. Okay. Velocity is the speed of these particles. So if I create a trail here, a node called trail, and go and say compute velocity, this trail, so look at that. Okay, actually, we don't need that wrangle, or we do, I don't know, I'm sure. I'm gonna go and no operation. So this velocity doesn't look right. Oh, there we are. It has created velocity because when I turn it, it created some real weird velocities. Okay, so let's look at our debris one more time. So I'm gonna look at it here. They're supposed to have velocity added on them, but they don't show it here. Maybe I should add trail, cut it and put it here. Okay, that's the issue. And the velocity dies off. Okay. Maybe it's the scale of the velocity which is too much. Yeah. So I can compute it after then, if that doesn't matter. Okay, so look at these ones. So you see that these points are generated and they have like kind of a speed with them attached to them. So if you turn this one, it shows the velocity. It's a very important attribute in Houdini, because that's why we keep it has a dedicated like kind of visibility of the velocity. So these points, so they get generated and they have a speed. In which direction? In that direction. Can you see that? So when I add that this trail node and set it to compute velocity, I can say that this is kind of add velocity. The velocity is getting added here, and it's gonna be inherited later on here. So here pop solver, you see that it says inherit velocity. Oh yeah, now you see that like things are going mad. The new points just like boom, like they are added, like a lot of particles are added, and those particles inherit the velocity. Actually, you can say that go and add to that inherited velocity. It's kind of like make it double. I don't know. It goes very crazy, but we'll set it back. So it's just like boom, just explodes. So you can look at the ghosted object here. So you see that how crazy it goes, like boom. You don't want that. So that's why I just set it back to inherited. But the beauty of this, activating this, is that you can create a kind of variance. A bit of like velocity, a bit of variance. So it's kind of okay. So now all the particles go everywhere like crazily. The reason is there's no gravity, there's no air drag. So there's no plane that they interact with, and yeah, there's nothing. So what you can do, you can go and grab the same, so again, beauty of Houdini, go grab the same ground plane here, copy that, bring it here. So you see that a ground plane is getting added, merge. I'm gonna save everything one more time, merge it to the particle, and maybe mature. So these particles now stay on top of the ground. If you see such a thing happens, instead of ground plane, you can use a grid outside and call it like ground object, and use that one as a static object inside and load it in. Where is it? Ground object, accept, and the interaction would be mature. Yeah, so you see that it just like goes around, but there's no air pressure now, or no gravity actually. So this is like the particle brain, isn't it? So this first one was the particle object, last one was the particle source, the middle one is the pre-solve. You can add a lot of pop forces. So let's say I add a pop force. This is a generic force. It can do anything. So I add it here. Nothing happens now because there's no force defined. But I can say that you can easily turn it into wind from X direction with some sort of like noise. I make it like a gravity, but like a very weak gravity. like minus. Oh, before adding this, before adding force, I just deactivate that one. A cool one is the drag. Drag force is actually not drag. You see, the error comes because this is particles, so it has to use pop drag. You have to use like kind of similar type of field. This is air pressure, air resistance. So I go crazy at the beginning, like 20. So you see that just go around, and then their speed just like slows down suddenly. If they get played a couple of times, I'm gonna load off, hide other objects. You see, just like it adds a very nice and gentle slow motion. Ba-bang, ba-bang. I like it. But not the air pressure is everything. You need like gravity. So I activate that one. I add a not like 9.8, which is the Earth gravity. Just like it. Usually it works terrible. I hate it. So you see particles go inside. I will show you how to fix that one as well. So I just use a like lower, like a more mellow gravity. It's okay that different part of your simulation has different like kind of physics. It's all about creating the illusion of like, that's why it's called visual effects. So that's a nice particle and movement. I want that gravity force has some noise in it and some swirling and like kind of and stuff like that. So it just like boom. But the swirl size was too large, you see? Just make it tiny. Nice. Maybe add a bit of like more turbulence. More. Okay. More amplitude. Yeah, that's kind of okay. But I want to kill these ones that go inside. So there's a pop kill that kills all the particles that you say. So it says that, okay, use a vex operation to kill them. It's simple. You turn it on, it has a predefined attribute on it. It says kill by condition. Here, the condition is all the particles will be dead if they are above 1. Oh, that's stupid. So the y direction of particles. So these particles, look at them. The y is on, like, go up. It says if any particle goes above 1, dies. But what we want is that if any particle goes under 0, it means like goes under 0, dies. Okay. I add that. So do you see that by a simple alteration here, anything that goes under 0 dies. And there's a bunch of other stuff here. So if you're not happy with the amount of your particles but you're happy with their physics, you can create an illusion of like kind of replication, like pop replicate, or what is that? Duplicate, replicate, pop, replicate, pop replicate. And suddenly you see, oh, lots and lots. So like each particle looks like 30 particles or 40 particles in a like kind of crazy way with a bit of noise on them. So it's just like it gets crazily busy, but comfortable with a memory. But we don't want that. Okay. So that could be a good debris. So if you're happy with that one, again, go back, cache it to $job. and it automatically goes to the simulation and stuff like that. Okay, so I see if everything is okay, so I'm happy with that. Save it to the disk. It caches the simulation. So we take the same simulation out of this and make it ready for rendering as well. So I go out. So ground is over there. Okay. So it's time to bring add a geo, and this is supposed. So you remember that we brought pan out of dynamic to the sub world again. So I do bring debris to sub level. So go and so dot import what from the debris simulation, debris sim. It would have been if I added a sim at the end of that, because at these cases it's easier to be. So I want to bring everything out of that, so that's why I say go and fetch everything. I don't want the ground actually. I could have hidden that one here, display geometry, but that one gets loaded. Okay, so what to do? I can say that tilde key dot object created by parentheses quote object level inside this simulation. And what was the name of that? It was particles or pop object 1. That was the name of the particle. I didn't name it because I didn't want it. And close parentheses, tilde key, enter. So okay, it's a bit stupid to keep typing this stuff as a mask, but you know what else we can do. So this one inherits velocity as well. That's important. So you see here it says add some velocity to your points, which is good. We loaded that one as well. Now we cache it, file cache on the disk from frame 240 to 280, and we save it into cache folder, call it debris. No, that was source debris. This is debris particles. Cache. Dot $f dot bgo dot sc. Okay. And cache it. It gets cached right away. It happens very quickly. And time shift as usual to exclude whatever is before and after. 280 and out. Make it as a cloud because it comes from cache. Blue, that's because it's cache. It's cache. Debris particles. Okay, so debris are ready. Just want to move on and turn these ones into some nice and very so actually we can use these ones as well. We can render them with different sizes, And also we can turn the same into like little fine dust as well. Let's have a quick break. Okay, so the same way that I sourced, so you see I created a source here, source debris. I can turn that off actually, which I created a bunch of particles that I sourced some other particles like these ones out of that. So the same way I use these particles to source volumes which is like very fine detailed particles or dust. So I'm gonna call it like I add another geo and I call it like, let's say sourcing dust, and inside that so again I object merge object merge particles. Definitely it's the particles in surface level. So you see that particles have traveled, so those debris have traveled into surface level. I use that cache, I bring it in, and okay, so there are 3 nodes that help us to create a good volumetric source: pyrosource, and then a noise, and then rasterizing those. So I'm gonna tell what each one does. So pyrosource is actually turning particles or objects into a bunch of emitting particles. So because these are particles, it's a bit like confusing, but let me say that I'm gonna bring in the other one inside that sourcing dust. So I'm gonna go, instead of that, I'm gonna grab Craig. Okay, so see that if I go here, pyrosource actually grabs that geometry and like scatters a bunch of particles around it, and that particle, like how many, is dependent on this particle separation. So, and you see that like I'm gonna source smoke. Of course no smoke is getting scattered or is getting emitted now. So I can say that go and surface scatter, or volume, or keep input. So this object that I loaded, that Craig, that like moving character, it's you see that it has put some points on it, and these points, this is important. You look at these 2 attributes, density and temperature. Each one of these points have those attributes, density and temperature, added on. So I go back, grab my particles that I had it from debris cache here. So basically this pyrosource, I'm gonna make the particle separation to like just pretty low. It's supposed to source some smoke. When you make it like that, when you make it fuel, it adds like other stuff like fuel as well. When you make it color, it adds color as well. So it's basically, these ones are nothing. This one doesn't do anything except projecting some attributes on the surface of each one of your particles. Now it's time to use that attribute. You say that, okay, this volume rasterized actually looks at those points and says, okay, give me some attributes, and I'm gonna convert those attributes into some volumes. So you can say, okay, what attributes I have generated here? It's density and temperature. So density, temperature, and bank. You get like this cloud of fog, but they are really low poly voxels. You can make it high poly and then wait until it rasterizes them. Actually, I just want to show you how to connect these two together. Before doing that, I want to connect this voxel size to this particle separation. They are in two different nodes, but I do some connection in one node, so you realize how these parameter reference works. So let's say you want, whenever you change this one, you want this other parameter changes accordingly, exactly. So you can say that copy this one and paste parameter here, paste a relative reference here, and enter. So you see that whenever I change this, the other one changes as well. That relationship can be proportional as well. You can say, you can divide by 2 that one. So whenever I change this, that one becomes half of this. So this is kind of what we call paste, like relative referencing. I bring it back as it was. So I want to relative, and I make that 1% and that one as well 1%. I want that pyrosource particle separation to follow this voxel size. So that's why I copy voxel size and paste relative here. Paste relative reference here. Enter. So here you see that it has the same one. So I'm going to turn on the brain and make that auto update on. So now if I go like, make it like half. Okay. So let's go back to the beginning where it's kind of like gets emitted. So this is like a very large scale particle. So if I go and make the particle scale like tiny, and if I go and look at, I bring ghost back, so we just see the rest of stuff as well, so we can have a better idea of the size as well, and also the density or voxel size. I make that like 2. Okay. Hide others. That's a nice voxel size. If you want to have some shadows, it's good to go up and make a skylight. So it just adds a skylight and some sunlight and just some shadows. That helps you to see some shadows on your particle. So that's a good. So this is not emitting smoke. We're gonna use this to emit the actual smoke. So this is not. This is just. You remember that we use particles to emit particles. We're gonna use volumes to emit volumes. Same way. Stripped on myself. So let's have a look at coverage as well. So this is too thick. I'm gonna make the coverage a bit down. Coverage attribute, I'm gonna use temperature as well. So temperature is gonna be used for both of that. That's two, or maybe not, just use density for coverage. More detailed. Okay, so if you're happy with that, let's add some noise in the middle as well. Actually, I will add two noises. One of them, so these noises, they create a not only an attribute, but also they can add an attribute and also add noise on that attribute. So I'm going to use this density and temperature that I had. It's stupid that in Houdini you have to keep typing things. You see that, like, this one adds a bit of noise on it. Maybe I just even increase that more. And particle size. Oh, that's too tiny. Should have lived with what I had. Was it 0.5 or 6? Yeah. Anyway, because that's not gonna be my final volume, I will emit volume out of that. So I'm gonna add some noise, an animated noise, which is nice. It's kind of like gets animated within the body of that. Could be like any type of noise, and what else you can do? So you might say that I want some areas to be empty, so you can remap your noise and make it crazy, like between -2 to 2, and then, or I'm going to remap it between -1 to 1 as it is, to have some like areas with less dense particles. The particle scale is here. Let me see if I can get better voxel size. Particle scale. Maybe a bit more. Slightly more. Filter size. Anyway, so noise. Oh, there's one thing that helps you as well, is this post processing. So you don't want any noise below 0, or any value on them below 0. So you see that this attribute noise, when I middle click, has created some attributes like this. There's plenty, but like this velocity and P scale and density, these are, each point here has these attributes added. So you can add another one, attribute create, and use that one to add or attribute, sorry, noise to not only add velocity one more time. I just wanted to make sure that velocity is definitely within the maybe I make that previous noise multiplication. Yeah, that would do slight or 1D. No, let's add it as it was. Okay, this one's gonna be this is gonna be a noise on velocity. It just helps me to reintroduce velocity to this thing. Okay, so if you're happy with that one, so this is, again, this is not the dust that is supposed to emit. It's just a volume that is used to emit volumes. These are like kind of, as you can realize, this rasterize attaches like kind of a volumetric voxel, just a cube full of fog on each particle with a bit of noise that we added in the middle. If you're happy, just cache it out. So this is gonna be job cache dust or source dust cache. It's gonna be $F BGO SC. Cache it. Happens right away, quickly. And then after that, we add our usual null to make a nice and neat output. Okay. So I'm gonna make a that's cache, so I use this. Cache. That was source dust. I'm gonna make the visibility on that one go up. So this is gonna be used for sourcing. So we need a new network, a new DOPNet, a new dynamic network. This new dynamic network, so the first one was for fracturing, the second one was for creating particles, the last one is for creating dust. So that's gonna be pan dust simulation. So the first one you learn how to bring like rigid body and stuff. Second one, how to create particles, and the last one, how to create volumes. So for volumes, so you need a volume object. So here we use smoke object, which is like can be used for dust as well. It's basically just a volume emitter or object, let's say, and you need to source it, like use a source, volume source, that looks at it's gonna look at the sourcing that we created, the source dust one. And it's gonna use a pyrosolver, which is the new brain. So we used that rigid body solver and then pop solver and now pyrosolver. That's how efficient visual effects works. We use different brains for different works. So this pyrosolver is added. This volume source is supposed to look at that one. It's gonna go grab and catch density, and that's okay. Let's see what we have. Okay, this is showing density here. Oh, so I forgot that. There's a kind of issue with latest version of Houdini. So it doesn't show. It has to show density, temperature, blah blah. Here it doesn't show because it's by default is on smoke. Just go to something else. Go back to smoke and source smoke. You see that they are added. So density is added, temperature is added, and velocity is added. So these ones are supposed to be sourced from the one that we created using this brain. I hope it works. Okay, so another thing. This is a simulation, isn't it? And it starts from frame 1. So I'm gonna say no. Frame 240 is. So later on I will show you how to create universal we create a controller here, or just like some sliders, and those sliders will be universal. So any time that we create a new simulation, it looks at that slider where the start frame is, and it grabs from that and applies it. We don't need to keep like creating it. So you see that it starts emitting, which looks terrible because the smoke object is tiny. If you ghost other objects in, you know that, okay, so it's gonna be like that size. And this voxel resolution is also terrible. Like, you see that these are like very giant boxes. So that's why you select your smoke object, and this division size is like 0.2, but we go like 5% or whatever. So now you see, like, you start to see something. Maybe more, but this is definitely not a dust. It has that like kind of nuclear weapon simulation mushroom. It's because there's no force in it. There's no gravity, there's no drag, there's no nothing. So we're gonna add them like one by one. I just make it more detailed. So first thing first, so you see that this dynamics is too huge, too big, so it has to calculate it every time. So but what if you just like would be able to say that, no, use a dynamically resizing tank. So there's a gas dynamic, resize fluid dynamic here that you can just chuck it in, and then you get this smart resizing gas tank that gets resized up to that final size based on the emission. So that's one thing. Then it comes to if you see like this like huge mushrooms, it's because like the volume source is the scale of the velocity. So you've got density and then velocity. So these scales are kind of like driving the size of this simulation. Velocity is the speed. So it carries on all the speed. But I can say that, okay, look at those particles, but don't borrow all the speeds from them. Just borrow part of it. And then you can say that, okay, I want to add some other stuff like turbulence. So these gas, like everything, turbulence, disturbance, dissipation, and stuff like that, these are like driving your gas or volumetric simulation. So I'm gonna use gas turbulence to create a turbulent field that drives velocity update here. You see that one? What's that one? Advection, which we don't want, you want to use now. So turbulence is 15, but it could be more. And I'm gonna save it, and I'm gonna add a gravity. It's not supposed to go high up. See, it just goes like up and then falls down, but it goes into the floor, which I don't want it either. I just want a nice ground. Again, I can go grab from the same ground I had it at the beginning. Bring it here. It could be merged before gravity or after, doesn't matter, but I just like to add it before. Merge. They behave mutually, like they interact mutually, and I think I have turned off the display here. Don't know why it doesn't show up. Anyway, let's see if it works. I just want to turn off the display. Okay, so the ground is there but not visible, but you see that it interacts with the ground, and also because of the gravity it just like falls down. Okay, so you have to play around. It's not bad at this stage, but it can be heaps better. But what you have to, so you see I get this like nice tours and stuff, and so for such a simulation it's nice, but it doesn't collide with the rest of your objects. It has to collide with these like Craig, and also like these smashing objects. So I want to create a collision world. So like geometry, this is gonna drive the collision, so I call it collision. Inside that I go object merge. So I'm gonna bring both of these. So if I turn off hidden object, so you can object merge as many as you want. I go grab Craig as it is, it's in. I go grab the broken the pan that has been brought back from simulation 2 and cached. It's there. So that's my these are the collision objects that are supposed to collide with my stuff. So what I have to do, I have to tend, so these are we assume that these are like solid objects, but they are empty. When we travel inside, you see that they are empty. There's nothing inside. So if the particle passes, if the particles would be lucky to hit the surface, can react, but if passes, gets inside, there's no way to understand that there's an object here. So that's why we convert them into like volumetric objects. A VDB is a good volumetric object. So I can say that VDB, so we have two types of objects, volumetric objects, volumes, like clouds and stuff like that, and also VDB. VDB is a kind of more efficient way of, VDB is not for Houdini, it's just like a, it's an open, so that's why it's called open VDB. It's an open source set of tools that is used by Maya, Houdini, and other applications. So here I go and say that VDB from polygon. Go grab that polygon and turn it into VDB. So this might look so because the voxel size is too big now, I think actually. So you see that the more VDB, the more larger it gets, the better voxel size you get. And okay. So it's gonna turn that into, like, I think yeah. So I'm gonna so you see that the name is the surface, and I gonna source point V. So this VDB objects, if I middle click on it, I want to see V, velocity, and surface is the collision, actually the collision surface. And I'm gonna say that this is gonna be velocity as well. So I've got velocity in it and I've got collision. So I can export it out as kind of out collision. And here in your simulation, in your dust simulation, it will be imported as a volume source again. But this time I don't say that source smoke. I say that this is gonna be collision. And I'm gonna go point at that collision set that we created, collision here, and that's gonna, yeah, that's collision. And you see that here it says I'm gonna look at collision and I interpret it as collision, but over there I didn't have collision, I had surface, because here I said that so distance VDB is surface. You can name it collision here, or you can go there and say that in your simulation and say that here, go and grab surface and interpret it as collision. Look at V, well, happily V was there, velocity was there, and interpret it as collision velocity. So, and density is there, and I think we're fine. So I'm gonna merge it into our simulation. So if we go back to our simulation, insurance collision, oh, okay, nice. Okay, let's see if everything is doing okay. So those there we are. I think I pressed, okay, so that's the issue. So I pressed W, that's why. Okay. So you see that like there are some empty interaction spaces, which is clearly a collision object. So when I go and say that bring those objects in, so you see that these objects are loaded some sort of weirdly. If I look at collision here, I'm gonna say that just look at hide other objects. Look at them. These are not empty objects. If I travel inside, I keep seeing these like kind of cubes. So your objects has turned into like kind of volumetric objects. And that volumetric objects, you should turn off the visibility of that. Inside your simulation, it's kind of, you see, it starts interacting with your geometries. So, again, if you're happy with the sim, you just, so we have to keep carrying these, like having this habit of $job instead of hip. And I'm gonna cache the area that I want. And so you have brought all of these back to sub level, and also your particles, your debris, and now you have to bring dust back. So that's the last step, and then you're free. So we're gonna bring dust back to sub level. Again, simple. You go, instead of dot import here, I use dot import fields because for some reason Houdini likes to call kind of these volumetrics as field rather than like other type of simulations. So I go grab my volumetric simulation down here, which is under dust simulation. So that's my dot network, and my object over there, what was the name of object in my dust? It's called a smoke object. You see, I grab it, I grab the name actually, and here say that's the object that I want to bring it. And what kind of, so I'm gonna hide all objects. So what field do you want to bring it? Density. You see that? Oh, it's just traveled from the world of dynamic, which is green, to the world of like, which is white, surface. And it's now you can apply shaders and render it out. Okay, so we've been through the whole, so no, just not finished yet. Again, I have to add file cache. Oops. File cache and cache it out to hard drive, to the address, what this right like kind of start and end, and then add a nice output indicator that this is gonna be out cache or cache. These are my naming conventions, so you can name it the way you like. So I like to, because it helps me to organize my word. So I usually go up and organize these ones as well. So let's say I'm gonna say that these are my so this is my sourcing. These are my sourcing. These are sub-levels that will be visible. These are my dynamic simulations. These are the things that gets rendered. We did all of that to render these. The breaking pan. Actually, the crag also is there. The ground and the crag, which is like the static objects. The pan that was breaking, shattering apart. Some debris and dust. Actually, this could be just dust if you don't want the debris, but they can add a bit of dynamism to your scene. Okay, so that was a whole journey from fracturing to adding particles and adding volumetric elements to your simulation as well.